Ultraviolet Non-Newtonian Fluid, or UBLEC, by Hannah Weber. Non-Newtonian fluid is a liquid that doesn't have a constant viscosity or flow. The liquid behavior is determined by temperature and pressure. Some examples of non-Newtonian fluids include ketchup, toothpaste, honey, putty, and UBLEC. For my experiment, I had two groups, tonic water UBLEC and tap water UBLEC. My control group was tap water UBLEC and my independent variable was the tonic water. I used the control group to compare the difference between each solution under UV rays, as well as to demonstrate how carbonation affects the UBLEC and the amount needed. Tonic water contains the naturally occurring compound quinine, which glows under UV rays. My three ingredients that I used were tonic water, cornstarch, and cold tap water. To create UBLEC, you need 2 parts cornstarch and 1 part water. It creates this type of consistency. Once my consistency was reached, I poured it into a plate, and you are able to see how it is hard with the spoon but soft when it's coming out of the bowl by itself. When being hit by a hammer, the UBLEC is hard because it's under pressure, but when I stick my hand in, the UBLEC becomes liquidy and my hand will sink. The same steps apply to tap water, though I needed less water than when I had used tonic water. Once again, when the solution reached the right consistency, I poured it into a plate and you can see how it is liquidy because it's not under pressure currently. And once again, just as in the other example, when I stick my hand in, it will begin to sink into the goo as it becomes a liquid. There is no visible differences currently under regular light. For UBLEC to form, an equilibrium needs to be found between the cornstarch and water. Unlike a normal solution, the cornstarch is not dissolved, but rather the particles are suspended. This means that when the starch particles move past each other quickly, they will hit each other and harden. If the particles are moving slowly, they will pass each other, resulting in a liquid form. If you do not find the equilibrium and add more water, the solution will become too runny, and vice versa. When you add too much cornstarch, the solution will become hard. Much like a solubility chart, when it's unsaturated, the solution is runny. When it's supersaturated, the solution is hard, and when it's saturated, the UBLEC is at its equilibrium. Since UBLEC's behavior is determined by pressure and temperature, we can use these to make the solution a liquid or a solid. When under pressure, the UBLEC becomes a solid, such as being hit by a hammer or squeezed. However, if you stick your hand in UBLEC without moving, your hand will soon become enveloped with UBLEC, as it is in liquid form and taking the shape of its container. The colder the solution gets, the harder it becomes, and the warmer the temperature gets, the UBLEC takes liquid form and will eventually become too runny and more of a white paste. Like I said, there were no visible differences in regular light. However, under UV light, the quinine begins to glow in the tonic water, resulting in the UBLEC to be a bluish-white glow, while the tap water is purple because of the light. This occurs because of a chemical reaction referred to as chemoluminescence, in which a reaction elevates a molecule to a higher energy level. The molecule then releases visible light until it reaches its ground energy level. So a chemical reaction occurs in the quinine of the tonic water, in which the phosphors of quinine absorb the UV ray and emit a blue light. The formula is ultraviolet rays plus quinine, the phosphors, equal blue light, or any light on the EM spectrum. Thank you for watching.